It's a good formula to have on your formula sheet, or just, remember it because you do use it quite often.
That's behind the z-square, right?
Yes. So now, number 6. At a snack bar, 50% order a drink, 35% order a snack, and 15% order both a drink and a snack. Calculate the probability of an individual ordering only a drink and the probability of the union. Okay. Okay. So let's see what we have. We have for number 6. So let's just call, let's do this, this way, sorry. So let's call ordering a drink A. Let's say ordering a snack is B. And order both a drink and a snack. When it says both a drink and a snack, do you know if that's referring to the probability of what? Of the union or the intersection? Intersection? Okay. So intersection, so that would be, let's say A intersect B. Order drink and snack. Okay. And then we know the probability of A, we are given to be 0.5. Probability of B, we are given to be 0.35. And then we're saying the probability of the intersection is 0.15. Okay, so now what is it asking? The probability of an individual ordering only a drink. So what would that be? What's the probability of someone ordering only a drink? 0.5? Okay. So yeah, we're already given that in the problem. Order a drink, probability is 0.5. So 0.5. And then,
Can you move it out a little bit?
yes. I guess I can just cover this. And then it asks for the probability of the union. Now, what is the formula to find the union of two events? Okay, yes. So we have here. Let's put it here. So probability of A union B would equal the probability of A plus the probability of B minus the probability of A intersect B. So in here we have the probability of A being 0.5. And then we have probability of B being 0.35 minus probability of A intersect B being 0.15. So that should be 0.7. Is that what everyone gets? Okay. So then that should be your answer. On the actual thing, on the actual paper, there's not, that option isn't there. So there seems to have been a slight typo. So let's call it A, B, C, D, E, F. Should be 0.5 and 0.7. Okay, does everyone understand that? Yes.
Isn't it the probability of only a drink? So when we have to subtract out the intersection?
Can you repeat that? What do you mean?
I mean, like, there's 50% chance to order a drink, but there's an overlap of 15% with drink and the other thing.
A snack.
Yeah, so like they could order a drink and a snack together. You only want to drink by itself.
Exactly. So you're given here 50% is ordering a drink, 35% order a snack, and then 15% order a drink and a snack.
And the question was asking for only a drink.
So it's only a drink. So we're given already here, order a drink. Am I misunderstanding you?
I'll ask afterwards.
Okay. Does anyone else have an issue with that problem? No? Okay. I could just be misreading this problem, so, yeah. Okay. 7. In a group of high school students, yes.
I would like to go back to that because I think the answer would be 0.35.7.
Okay.
Is that what you got? Yeah, that's what I was thinking too.
Okay, so can you explain how to do that?
Can you go back to it?
Oh, yes, of course.
So the first question says calculate the probability of an individual ordering only a drink. So only a drink would be
Drink 35%.
okay, so only a drink would be 0.5, never mind. And then the probability of the union, okay. I'll just talk to you later.
Okay, well, no, because if you,
for me to verbalize what I'm thinking.
but if you do have the same issue as him, like I must just be misreading the problem. So if you guys agree that the answer is on here, then I would rather, we get the answer to the problem rather than me telling you the wrong answer. So.
Because the way that
I think I can explain.
Okay.
When it says 50% order a drink, it's saying like in general 50% is ordering a drink. So 15% order both a drink and a snack. It's inside of the 50%. So you have to subtract like 0.5 minus 0.15 to get 0.35.
Oh, I see what you're saying.
Only the drink.
Okay. That does make sense. Okay.
Thank you.
Okay. So that's, So that would mean that, okay. So you're saying it would be the probability of A minus the probability of the intersection. So A intersect B. So then that would be 0.5 minus 0.15, and that's why it's 0.35. So that would mean, so ignore that, and it is that one then. Okay. Does that make sense to everyone?
Why would you do that? It says in the question, 50 order a drink, 35, et cetera, et cetera. I think they're trying to make it more than what the question's asking, in my opinion.
Okay.
What it's saying is that in 50 order drink, 35 order snack, 15 is the percentage of 15 is in 50 and 35. So to subtract this drink and a snack, you'd have to subtract the 15 from those two. So you add those two and subtract the 15 to get the intersection of the other two. I don't know if that last one makes sense. What is that? What are you trying to get with that last one?
So, okay. So I do see your point, and I do see your point. So,
Is the way that I view this kind of problem is like with the circles. So that's why I think we should subtract, because if you put like 0.5 here, you will be counting like twice. You know?
Yeah. Okay. So it does seem like in this problem, when it says 50% order a drink, I do believe that that does include the 15% that order both a drink and a snack. Because it's saying like overall, like from all the people, 50% order a drink. So that does mean like it would include the person that orders a drink and a snack. So that is why in the 50% you would take out the 15% that order both as a drink and a snack.
Yeah.
So and since it's asking only a drink, then does that make sense? Okay, yeah. So so it would be, the answer would be C. Everyone good? Yeah, it is confusing, so I understand. Even I got it wrong at first, so. All right. Okay, so number 7. In a group of high school students, 55% of students did well on their last test, and 35% of students had done well on their test and eaten breakfast that morning. Given that a student did well on their test, what is the probability that they also ate breakfast that morning? Okay, so let's split it up like we did for the last one. So we have 55% of students did well on their last test. So let's just say that A is that students did well on their last test. And then we have, and 35% of students had done well on their test and eaten breakfast that morning. So what would we say is B? Okay, that would be good, yes. So we have B, so students that ate breakfast that morning. So then what is this one? Students had done well on the test and eaten breakfast that morning. What would that be? A intersect B, okay. So A intersect B, we have student did well on test and ate breakfast that morning. Okay, so we're given that the probability of A is 0.55. And then what is that? So that 35% would be the probability of what? Yes. So A intersect B would be 0.35. So yes. Okay, so it's asking for, so it says given that a student did well on their test, what is the probability that they also ate breakfast that morning? So how do we find that? The probability of something given something else. Do you remember this formula? Let's say A, B equals probability. Do you guys remember that formula? Okay, so that would be what is the probability of A given B, correct? So here it's asking, given that they did well on their test, so the given is A, not B. So here, we can change this up to this problem to be the probability of B given A. And we can say, just to be consistent, that is that, and then probability of B. Now, the probability of A intersect B and the probability of B intersect A is the exact same thing, but I'm just trying to be consistent with the switching. So, okay. So that means that the probability of B given A would be this, which it's already given, to be 0.35 over the probability of, oh man, did I just mess that up? Yeah, just kidding. So this is actually A, okay. So this is supposed to be A, and this is supposed to be B. Yeah, sorry about that. Okay, yeah. So then it's supposed to be, yeah, so 0.35 and then probability of A, so that's what we're given, which is 0.55. So then that should give you 0.64. Make sure that I am correct in that. Yes. Okay. All right. Does anyone have any questions with that one?
Are you sure?
Yes, of course. Okay. So now number 8. A teacher is seating 8 students out of 25 in a specific order in one row of desks. How many ways can she place students? So, how would you guys go about doing this problem? Counting, okay. So which one is that one? Would that one be maybe a combination or a permutation or something like that maybe? A what? Combination? Okay. So for combination, that's the one where order matters or order doesn't matter. So for combination order does not matter. So here it's saying, let me see, students in a specific order. So if it's a specific order, that means that the order does matter. So that would be a permutation. Okay. So for permutation, let's say number 8. Okay. So we know that the formula for that is what's written like this. And then we have n minus little n over, well, under big N. So in here, big N would be the total number to choose from. So total, let's say total students. Total students available, just to make it a little clearer. And then here the little n would be from those total students, how many are you choosing? So students chosen. So we have here, so n, in this case, what would be big N here? 25, yes. So what would be the little n? 8. Okay. So then if we put that in that formula, so big N 25 factorial over 25 minus 8 factorial. So 25 minus 8. What is 25 minus 8? 17, 25. And then we can simplify that a little bit. 25 times 24 is 23 times 22 times 21 times 20 times 19 times 18 times 17 factorial. And then we can cancel those out. And then this part, so all of this, would equal 4.4 times 10 to the 10. So that is a very large number. Does everyone see what I did? Does that make sense, how I factored out, crossed out the 17? I just did, okay. So that is simply, since I took out the 17 factorial, that is just 25 times 24 times 23. I just didn't want to write it all over again. Okay, well, I'm already halfway there. Okay, so yeah, it's just that is that.
That's what that equals.
Yeah. So. And then I guess here, that would be 44 billion. Now, there is an easier way to do this in your calculator. Are you guys aware of this? Because it's a great time saver. So, what I have is a TI-84 Plus. I don't know what you guys have, but I can show you how to do it on this one. So, okay. So for permutations, you would put whatever big N is. So here would be, you would do 25, and then you hit math, right here, math, and then you click the left arrow so that you're highlighting PRB, and then you click the number 2 so that you click the NPR. So you press 2, and then that's what it shows. And then you go ahead and you put whatever your little n is. So here little n is 8. So you click 8, and you get 4.36, which is roughly 4.4, and then e is times 10, like to the 10th power. So that's just another way of doing that. Okay. All right. Now, let's see. I think we can go ahead and do number 10. Number 9, I don't know, did we go over combinations? I'm not sure if we went over both permutation and combination or just permutation in class. So, do you know if we went over both of those? Do you remember?
I don't remember.
Okay. I wanted to go over 10 because that one dealt with things that because combinations and permutations are roughly the same. Just order matters for permutation, and for combination, order does not matter. And I guess I can give you the formula for.
Wait, you said order matters for permutation?
Yes, order matters for permutation, which is why we used it for number 8, where it asks for, it said in a specific order. So that's why we use permutation. So for combination, yeah, so the formula for that would be C or N. Okay, so we see, sorry. So the difference really between the permutation and the combinations is the little n factorial, basically. From
I think we did go over that, and there was a trick on the calculator for that too. Right?
yes, yes. So for that one, it should be, it's basically the same thing, except for, okay, so let's pretend that for number 8 is combinations. So we would do the exact same thing. So we'd plug in n, so our big N. So big N is 25. So 25. And then math. And then once again, go to left arrow where it's highlighting the PRB. But then here, you would go ahead and click 3. You can't see it on my calculator because my calculator is broken or something. So it should be your third selection. So I just click 3, and you see how there's a C now. So before the P was for permutation, and now here's a C for a combination. And then you would plug in your little n, and that would give you that number. So as you can see, when order does matter, our number is a lot higher than when order doesn't matter. So we had 4.4 billion possibilities when order mattered, and now we just have, that's what, 1 billion something possibilities. Yes. Everyone good? Okay. So, let's see. So let's do 10. So, number 10. A researcher is studying how often a beekeeper is stung by a bee in a given year. What type of distribution would be used to solve a problem related to this topic? Does anyone have any ideas or any thoughts? No? Okay. Using as discrete? Why would it be discrete?
Because it's like a given number.
So for this one, it would actually be the Poisson distribution. And that is because pretty much the definition of Poisson, I'm going to put it here, so number, 10. So it would be Poisson, great. Okay. So Poisson distribution. So let me pull this again. Okay. So Poisson distribution is useful when describing the number of events that will occur during a specific period of time or in a specific area or volume. Yeah, that's simply, sorry. You can't really see it completely, but that's pretty much just like the definition of Poisson distribution. So in this case, it's asking for how often a beekeeper is stung in a year. So you're describing the number of events occurring in a period of time. So how many times they're stung in a year. That's why it's a Poisson. Does that make sense? Yes.
What's the definition of discrete?
Discrete. Okay, does anyone have the definition of discrete? No? Okay. I don't have the definition, but I have it too. Thank you. I just didn't have it written down. So, okay, let's see. Okay. Okay. So here, so it talks about the probability distribution of a discrete random variable. Or, hold on, I don't think this is it. For specify this probability distribution with each possible value that the random variable can assume. What is it asking? What distribution? Yeah, so I guess this would just be, yeah, between discrete and then what was the other option that's not discrete? Continuous. Yeah, so would it be countable? Behavior is summed by a beam. So just like the distribution would be the Poisson distribution. When it's talking about random variables, that would be something different. For number 11, we're going to skip that one because it deals with a distribution that we did not cover in class. So, okay, so number 12. Which of the following is not a characteristic of a binomial random variable? Does anyone know? A? Okay, so trials are not independent. Okay, yes, very good, because trials are independent for binomial. Yeah, so basically binomial random variable, so it's all of those, but then so it would be all of these except for the A. So that one should actually be, so trials are independent. And then, yeah, so, and identical trials and two possible outcomes only. Two possible outcomes. And usually we say that those outcomes are what? For binomial. Do you remember? So, okay, so yeah, like success and failure is usually what we go with. Yeah, I'm literally just rewriting what this says. X is a binomial random variables, yeah. So X is binomial and then each trial would have the same probability of successes. Or let's say probability of S is same for each trial. Okay. Now, for number 13, it says a class meets for 90 minutes. Any student who arrives between 1 and 15 minutes late is marked tardy, while any student who arrives after 15 minutes is marked absent for the day. What is the standard deviation of the distribution? Assume a uniform distribution. Okay, so there they are telling you what distribution this is. So that's pretty good, you know, you don't have to start trying to figure it out because you're already given the distribution. So for uniform distribution, number 13. Okay. So there's a formula for the standard deviation of the uniform distribution. So we have that sigma is D minus C over the square root of 12. It's a very odd formula, but that is what it was. So here, does anyone know what D and C would be? Okay, so let me also put here the general formula. So we have D minus C over 1, and then with C so basically, what is the range that someone could come in at? Like, how many minutes would be the least minutes that you can come in to class, or how many minutes would be the most that you can come in to?
1 is the least, 15 is the most.
So that would be in terms of tardiness. But in general, if the class meets for 90 minutes,
So
so
90 would be the latest you would be.
so then what would be the least?
A minute? 1?
So it would be, I guess, like right on time, right? So
Okay.
so it would be 0, right? Okay. So here it says that x is less than or equal to D, but greater than or equal to C. So what would be C and D?
0.
Okay. So C would be 0 and D would be 90. So that means that here we would go ahead and put 90 minus 0 over the square root of 12. And that should be 25.9, which is roughly 26, and that should be the answer. Is that what everyone gets? Okay. So then number 14 goes along with the previous question. And it says, from the problem above, what is the probability that a student is marked tardy? So now, if you look back, so it says tardy. So in order to be marked tardy, you have to be between
1 and 15.
1 and 15, very good. So there's another formula. 14. So, okay, so if you want to find the probability of x being greater than A but less than B, then it would be B minus A over D minus C. So in this case, what would be A and what would be B? One and 15. Okay, yes. So A is 1, B is 15. So 15 minus 1 over 90 minus 0, same as 14 over 90, which should be roughly 0.16.
Yeah,
0.177? So you, okay. So does everyone else get 0.16? Okay. Good, good. Okay, so now is it 1? Okay. Do you know if we covered standard normal distributions? We did.
Yeah, no, I don't remember the standard normal distribution.
Okay.
I don't think so.
Let me see. Oh, what is your score? Okay. Then let's just go to 17 because I know that we do a lot with C-scores. Okay. So 17 asks for the probability of a C-score that is less than 1.4. Does anyone know how to do that one? No? Maybe by using the tables? Do you guys have your tables, by the way? I do see some tables. Okay. Okay. So using our tables, how would we do this problem? No one?
You just locate 1.4.
Okay. So if we look at our tables, we see here 1.4. So we're given this for this number. So what does that number mean? So this is giving you the probability of what?
Area under the curve.
Okay, so the area under the curve to the what side?
Left.
To the left. Okay, so you see here there's a little guide for you. So whatever number we find here is supposed to give you the probability of everything that's shaded. So everything to the left of that C-score, right? Okay. So that means that here it's asking for 17. It's saying for the probability of a C-score less than 1.4. So it should be the probability that C is less than 1.4, right? Is that what it's asking? Okay. So here we found that C-score of that is 0.9192. Is that correct? Yes.
Would you subtract 1 from it?
Okay.
Because it's not, it's like this tells you less than or equal to.
Mm-hmm.
I don't, you know how that, like, some of them, the equal to matters, and then you have to subtract the equal to out?
Yes. So in this case, would that be one of these cases?
Less than, no, you're right.
Okay. Does that make sense to everyone? Okay. So it's asking the probability of a oh my bad. C-score less than 1.4. So the C-score, that should be the answer, unless I'm misinterpreting this problem again. Okay. So the probability of a C-score between negative 2.52 and 0.76. So we have probability that we have negative 2.52, Z 0.76. That's greater than. I guess I should have put it the other way. Oh, yeah, it goes this way. Greater than that, less than that, yeah. So how would we go about doing this one? Okay, so we can find, let's do it separately. So what is the probability that Z is negative 2.52? So we have C, or let's not, it's negative 2.52. So that is, I feel like I'm writing this wrong. Probability. If we use a table, it says here .000059. So that should not, let me see. Less than or equal to, yeah. Because whatever number you look at here, we said it was whatever, it's that number and to the left. So that, yes. It should be less than or equal to. So that means that less than or equal to is less than. Okay. And 76. 6.77. 64. So let's draw this because I think that may help. Okay. So it's asking for the probability that C is between these two numbers, right? So how do we find that? Add them? So if you add them, what does that give you? Like what, in terms of this? Okay, so when you look at these tables, whatever number you're given, we establish that it's the probability of it being that number and everything to the left, correct? Because it says here, cumulative area, I guess from the left, but just like cumulative area, so that way, right? So it's that C score gives you the area of everything of like from there that way. So if we're only trying to find from here to here, how would we do that? So someone said subtract. So what would we subtract? 1 minus 0.0059. Okay, so if you do that, you would be doing 1, so this entire thing minus this. So you would be getting from here all the way this way. So, but we're trying to find just from here to here. So instead of 1 minus this, we would do Okay, so you're saying the C-score of this, so 0.7764, because that's what the probability of this, and everything to the left, minus this part. So it should be 0.0059. Okay. 7705. Okay. Is that what you guys get? Okay. Does that make sense to everyone? I feel like C-scores are pretty important. Okay. Let's do that one. Okay, so 19. The mean weight of a house cat is 14 pounds with a standard deviation of 2.6 pounds. What is the weight of a cat with a C-score of 1.78? Okay, so we're given mean weight of a house cat. Okay. Okay, so that's the mean weight. So mean, we're given 14. And a standard deviation of 2.6. So what is the weight of a cat with a C-score of 1.78? So we know that the C-score is 1.78. And we're trying to find the weight of a cat. So we can just call that variable x, and that's what we're trying to find. So how do we do that? Does anyone know?
Isn't there a way to do it on the calculator?
There might be, but I don't know that. I don't know how to do that on the calculator. I know that there is a formula that we have actually worked with before today.
Is it the z equals x minus the mean over standard deviation?
Exactly. So we use that and we just kind of switch the variables around to find what we're trying to find. So we do know that there's this formula. And then we're given everything except x, so we can just kind of rearrange this formula to make it into what we're trying to find. So let's see. So we can do z times sigma equals x minus mu, and then we can add this mu over there. So c sigma plus mu would then equal x. Does that make sense how I did that? Just algebra. Okay. So then to make it pretty, I'll just start with x in this way. And then, so we can find x by doing z. So z is 1.78 times sigma, and sigma is 2.6, plus mu, and mu is 14. And what does that give? Okay, so that should give 60.28. Is that what everyone gets? No, did I do something wrong? 1.78 times, oh, I did times 26, just kidding. 1.78 times 2.6 plus 14. Yeah, you guys are right, yes. So that is 18.628. Okay, good thing you guys are checking the answer. Okay, so does that make sense? Okay. So 20. So it's referring to the above problem. So from the problem above, what is the probability that a house cat weighs less than 13 pounds? Okay, so how do we do this one? Can you repeat that?
13 minus 14 over 2.6.
Okay, so that would be saying that the house cat is 13, but we're asking for the house cat weighs less than 13 pounds. So how would we do this? Any other ideas? Okay. So probability the house cat weighs less than. So we're asking for that x is less than 13. Let's see. So if we go ahead and do the way that you said it, so let's say, yes, sorry, keep doing that. Okay, so let's do it like this. So yeah, so let's do, so the 13 minus mu 14 over sigma. Oh, whoops, I put sigma, 2.6. So that's gonna give a negative number. Negative 0.38. Okay. So this would be that x is 13. So if we're saying that x is less than 13, how do we find that? So here, negative 0.38, 0.3520 goes along with this z-score. So we have the z is, what did I say, 0.3520. That is the probability. Keep doing this wrong. Hold on. I'm writing this wrong. So it would be the probability that z is negative 0.38, 0.3520. That would be less than. Sorry, I keep writing everything wrong. Okay. So that gives you the probability that x is less than 13. Let me see. Actually, you're correct because it does, okay, yeah. So since the z is giving you everything to the left, so yeah, I apologize. Yeah. So that would be how you do it. So since it is asking for everything to the left of that, so everything less than 13, that would be how you do it. Okay. So that would be your answer. Parameter statistic. I don't know if we really went over parameter statistics. Okay. So number 23, we skipped a few. The cost of tuition is approximately normal, and average cost of a year's tuition in Florida is $11,750 with a standard deviation of $2,600. You select 40 students from across the state at random. What is the probability that their mean tuition cost is less than $10,000? Okay. So what are we given in this problem? Okay, so it says approximately normal, so that means that it's normally distributed. It's a normal distribution, right? So that makes everything easier just by telling you that. Okay, average cost of a year's tuition in Florida is $11,750. So what notation are we using to signify this number? So it's saying the average cost in Florida. Mu? Okay, yes. So mu would be 11750 and standard deviation. So what's the notation for that one? Sigma, very good. So sigma 2600. You select 40 students from the state, from across the state. So what is 40? What notation? N, yes, a sample size. What is the probability that their mean tuition cost is less than 10,000? Okay. So we're trying to find the probability that X is less than 10,000. Right? Is that what we're trying to find? Okay, so how would we go about doing this one? It's very similar to one that we already did. What equation are we using? The C-score one, exactly. We should be very familiar with this one already. So we know that X minus mu over sigma. But this one, we are dealing with, they give you the sample size. So we would do divided by n. Is that correct? I guess we can give it a shot. So we know that X, let's just say X is 10,000 over here. So 10,000 minus mu, 750 over 2600 divided by 40. Okay, so here I get negative 4.26, more or less. Is that what you guys get for the C-score?
Yeah.
Okay, so then based on that, we have to look at the probability for the C-score is less than negative 4. Sorry, negative 4.26. So if we try to look for that one, so negative 4.26. We see here that the most negative is negative 3.5. So what does that mean that the probability is for negative 4.26? 0? Yes. It's practically 0. Okay. So the probability that the mean tuition cost is less than 10,000 would be about 0. Okay, so we're looking, we found based on the numbers that were given, we find the z-score, right? We plug it into that formula, and we get the c-score is negative 4.26. So when we try to look at the probability for that c-score on here, we see that the most negative on this table is negative 0.35. And we see that there's a trend that as you get more negative, the probability gets smaller and smaller. So you see here that the least is 0.001. So basically anything smaller than that is basically 0. Okay. So Now it says from the problem above, calculate the same probability, but instead asking 17 students instead of 40. So how do we do that one?
Do the same thing.
Everything over again, just plug in 17.
Okay, so let's give that a shot. So we have number 24. So if we do that, so we have x is 10,000 minus 1,750 over 2 zig 0, 0 over 17 equals. So 2.78. Okay. So then if we look that one up, negative 2.78. On here, we see negative 2.7 and then 8 is 0.0027. Yes. So then that would be it. Now, if we weren't told that this was normally distributed, would we have been able to do this? No. Why not? Or what would we have done instead? Do you know?
Since the sample size is small, we use the concentration method.
Exactly. So the t tables, right? Yes, very good. So the only reason why we did use the z for such a small sample was because we were already told that it was normally distributed. So if we hadn't been told that, we would have just used the t tables for that. Now, what is the cutoff? What is the sample size that we need to have? 30. So we have to have greater than 30, or is it greater than 30 or 30 or greater? 30 or greater. Okay, yes. Very good. Now, do you know what theorem that's going with?
Central.
The central limit theorem. Very good, yes. So that is stated in the central limit theorem. Okay. Okay, so 25. 65% of all UCF students have been to the campus Starbucks at least once. You ask a random sample of 150 students if they have been to the Starbucks before. What is the probability that more than 70% of these students have been to the Starbucks? Okay. So 65% of all students. So number 25. So we know that the sample is 150, right? Probability. Okay, so here, what are we using for this one? Because we're not given a mean or a standard deviation or anything. So what does that mean? Hmm?
Would it be binomial?
Binomial. Okay, so what is the probability that more than... You ask if they have been to a Starbucks before. So you're asking them a question that they answer yes or no, correct? So it's not... So it would be, yeah, it would be like a binomial because it's either you have been or you haven't. So then what does that mean? How do we do this one?
Proportion.
Proportion, okay, so it's a proportion one. So what's the formula for that? What do we use? We know that we're using the proportion. What do we do? No one? So if I was students have been to campus at least once. Okay. So we are given 65%. More than 70 have been to Starbucks. So you're told more than 70%. Okay. 70% more than. Greater than. Probability. Okay, so as proportion, what do we do? Oh, I was just trying to like picture it. So it's greater than. It's asking for the probability of more than 70%. Okay, so this is like a backwards kind of thing, right? So, okay, so if it's saying 70%, so 70% is the same as 0.7, right? And it's saying here 75 or 65. Oh yeah, you can't write. 65. So the C-score of what? Are we doing the C-score of 0.65 or 0.7? 0.7? Yes? Okay, so if we try to look for 0.7 on here, the thing closest to 0.7 seems like it would be, let's see, that's 15 versus 19. So it seems like it would be 0.52. Do you see that? So 0.7 is between these numbers, but it is 15 away from this one versus 19 away from this one. So it would go with this one. So that's 0.52. So Z-score probability of something, or it should be less than a number. It's 0.7, and we found, I guess that should be X. I'm sorry guys, I'm just writing everything wrong. So then we found that X, or I guess I shouldn't put it X, but the Z-score is 0.52, I said. I apologize. Okay. So now what? So that's giving you everything less than that, and it's asking for everything more than that. So what do we do? Okay. %% of students. So 0.52 is a Z-score. Let me. Z-score here of 0.52, and that is when this is 7. So this would therefore be 3, or let's say 70%. Once again, I'm sorry that I keep doing everything wrong. But okay, so that's Z. So we just found the corresponding Z-score of 70%. So, and it's asking for everything more than 70%. So what is the probability that more than 70% of these students have been to Starbucks? Let me see something. So we said 0.52. I feel like I'm doing this wrong. What is probably that more than 70%? Yes.
Why are we using Z-score instead of the
Binomial tables? I think that's why we're doing this wrong. That makes a lot more sense, yes. I'm sorry. Yeah, that's how the numbers aren't matching up. Okay. The only thing is that for binomial tables, sample of 150. So it only goes up to 25.7. Yes.
I think we used the wrong formula.
We're also using the wrong formula. That's very possible. So what's the formula then?
It was the Z-score equals P hat minus P divided by the standard deviation of P hat.
Okay. So P hat minus P divided by the standard deviation of P hat is, oh, sorry. Is that what you're saying? Okay. So if we do that, then what would be P hat and what would be P? So
P hat is 70%.
So then P would be 0.65. And then standard deviation, but we're not given the standard deviation.
You use the formula to get the standard deviation of P hat, which is 1 minus the square root of P times 1 minus P over N.
P, can you repeat
Times
that?
1 minus P.
1 minus P.
All right, P times 1 minus P.
P times, okay. P times 1 minus P
Over N.
over.
And you square root the whole thing.
So that would then be that.
Yeah.
Okay, that makes a lot more sense. So then P would be 0.65 in here, and then N is 150. So 0.65, 1 minus 0.65, N is 150, and then the square root of everything. 1 minus 0.65 times 0.65 divided by 150, the square root of everything. So that gives 0.0389. And then when we plug that into here, 0.7 minus 0.65 divided by 0.0389, that gives 1.285. But I guess we can just round to 1.28. Just because that's let me see. We can say 1.29, but usually 1.28 is a number that we like. Let me see. So when we look at 1.28, .8997. Yeah, so that gives, so this is supposed to be 0.2. Okay, so that's to find, this would be to find Z, correct? This would be to find C?
Z.
Z, exactly. So then when we look at this number in here, .28 is 0.8997. So the probability that Z, once again, it's less than 1.28 is 0.8997. Okay, so because that would give you, since we put the wrong number on here, we have 0.8, oh just kidding, this is a Z-score. So the Z-score of 1.28 is giving you everything to the left of this. So if we do 1 minus this, it gives you this, which is what we're trying to find. So yes, so we were trying to find whatever is greater than. So we do 1 minus 0.8997, and that gives 0.1003. Yes, very good. Thank you for saving the day. Okay. Does that make sense to everyone? Yes? Okay. What time is it? 50. Okay. I think I might actually have to wrap it up here just to give everyone time to, I guess, ask any questions if you have any. And we also have to clear the room so the other session can come in here. So the answers to this will be posted, as I said, on the UCF studyunion.wordpress.com. And yeah, guys, I just like good luck on your finals. There's still like 2 weeks, well, like a week and something left.
It's not. It's Monday next.
Okay, so a week left to study, and then you do get to have, I believe she said 4 formula sheets. So you have plenty of room to write like everything and anything you can think of, including like examples or formulas or anything you want on those formula sheets. So I think you guys should be fine. Okay, well, good luck. And thank you guys. Sorry.